If you want to store the marks of 3 students, you can just store it in 3 different variables. But if you want to store marks of 100 students, you don't need to store it in 100 variables. You can just store it in list data type in Python. Hello everyone, my name is Ankur and welcome back to another video on our series on Python basics. And in this video, we'll discuss the list data type in Python. A list is a compound data type in Python. It means instead of just storing one value, it stores multiple values in it. So let's see how we can write a list in Python. A list can be written by comma separated values in square brackets. So this is our list and the index ranges from 0 to length of the list minus 1. So here, so the indexes will be 0, 1, 2, 3 and 4. So a list can contain values which have same data type as well as if they have a different data type. For example, if we have a list in which the elements are, the first element is a number, an integer, second is a string, and third is a boolean. So this is also a valid list. It's a valid syntax. But in real world, these kind of lists are never used. Most of the lists have the same data type in the real world. Let's open our IDE and try to create our own list. So if you want to calculate the average of the marks obtained by 3 students, let's say the first student obtained 70 marks, the second student obtained 80 marks, and the third student obtained 90 marks, right? If I tell you to calculate average, so it will be student 1, 2, and 3, add them and divide by 3. So let's print our average. So as you can see, this is some easy way to calculate the average. But here, our data is very small, right? We just have 3 students. But what if we have 100 students? So now if I want to calculate the average of 100 students marks, okay. So let's just comment this one out. I'll create a list as I mentioned. List can be given in comma separated square brackets and the value should be separated by comma. Let's take the marks. So these are the marks, right? So if I want to calculate the average, now if I want to create a sum of this, I can use for loop on this list. For mark in our list. So as you can see, so to calculate the average in this list, what we need to do, we need to add all these marks, okay, and divide by the length of the list. So here, let's first calculate the length. So length will be our total number of students. So there is an inbuilt function in Python, it's called len, and if you pass your list to it, it will return an integer value, it will be the length. Okay, I'll use the for loop to calculate the sum of all these elements. So in order to use for loop on the list, what you will do, you will write for mark in students. So student marks is our list and mark is a variable. So when we iterate our the student marks list, the mark variable will fetch each value one by one. So what do I mean by that? Okay, let's see. I'll just try to print. So now what will happen? As you can see, each time we are reading a single value from the list, right? So now here, if you see, so instead of printing it, I can just calculate the sum. So let's create a variable sum equal to 0. What I will do, sum equal to sum plus mark. So what will happen here, in each iteration, we will add the marks of a student through a variable called sum. So we are basically adding it each time the marks to the previous value of sum. Okay, so now after the for loop is complete, the sum value will change. Let's try to print it. Sum value before for loop. Okay, let's print the value before the for loop. And similarly, I'll try to print the value after the for loop. Okay, let's run our program. As you can see, this is the total sum. And what is the number of students? Total students are, so there are 12 students and the total is 554. So how you will calculate the average? I'll just comment out these print statements. So average will be sum divided by total number of students. So average marks are, we'll just print our output. You can see this is the average that is coming. So this is how you use a list to store multiple values of same data type, and this is how you use for loop to iterate over the list and to perform different operations. So here we just try to perform the to calculate the average. So now let's check some properties and some operations that you can perform on a list. Let's say we have a list L1 and it has some values 10, 20, 30, 40, 50, 60. All right, let's say till 80. So if you want to access the first element, if you want to access the first element in the list, what you can do, you can simply write the index that you want to access. If you run your program, you can see you are able to print the first element here. So in the similar way, if you want to print the second element, you can change the index to 1 and so on, right? But what if you want to directly access the last element and you don't know how many elements are there, right? You can simply write -1. So if you give the index as -1, it will give you the value of the last element. As you can see, 80. So 80 is the last element. So it has given us the index of the last element. Similarly, you can also change the values. Change values at particular index. Okay, so let's try to do that. So if I say L1 1 is 22. So if I try to print my list now, you can see we have changed the value of the second element from 20 to 22. If you want to insert an element in the list, how you can do is L1 dot append. So append is an inbuilt function in Python library, and You can perform the append operation on the list. So what it will do, it will just add the element in the end of the list. So now if you print your list, you can see it added a new element at the end, that is 90. So here you can see the lists are not like variables. So they are mutable. They are not immutable. It means you can change the values in a list. Okay. You can also assign list to another list. Okay. So what this will do, it will create a new list. If I run my program, okay, you can see L2 and L1 are different. So one thing to note down here is when you assign or create a new list by using this assignment operator, it's not creating a copy of your list. What it's doing is it's just creating a shallow copy of your list. What I mean is like it's just pointing to the elements in your old list only. So it just creates a new list and the pointers point to the same values that are there in your old list. Let's demonstrate it. If I just say L2 1 is equal to 23, right? So it should change the element at index 1 in list L2. Okay. So now if I try to print my L2 list, so what will happen? Printing list L2, you can see we have changed the second element, right? From 22 to 23. So what will happen to the list 1? Let's try to print that one as well. As you can see in the list 1 also that element is changed. So it proves it was just a shallow copy. So L2 is just a shallow copy of L1 and it's pointing to the same elements that are in the list 1. Okay, so it's basically you can see you are referring to the elements in the list 1. So whatever you perform in list 2, it will also happen on the list 1. So there are some other ways instead of just assigning L2, L1 to L2. So there are other ways to copy a list. We use the inbuilt function called copy. All right, let's try to create a list. I'll call it L3. L3 equal to L1 dot copy. So this will create a copy of the list. So you can see L3 is exact replica of L1. So what will happen if I try to change the element 1 in L3? Let's try to change this to 24 and also try to print the list L1. Let's see the value changes in that also or not. So now you can see what happened here. When we try to change the value of the element at index 1 in list L3, you can see the value is changed in L3 but not in L1, right? So here when we try to create a new list using the copy function, it created a new list. Okay, so it's not just referring to the same elements. Okay, let's try to use this slice operation. So if I want to create a new list L4 from L1, what I can do is I can use the slice operation. So this will also create a new copy of the list. Okay, if I try to print the L4 and also the L1, you will see it's just a new copy of your L1 list. Slice operation also helps you to modify your list. Let's say I want to modify, let's say I want to insert some elements on our index range in our list, right? Let's say I want to insert from index 2 to index 5. I want to insert 11, 12, and 13. 23 now. Let's do 13. Okay. So what will happen here? So what will happen here? We will insert these three values from index 2 till index 5. Okay. So from index 2 till index 5. It means before index 5. So basically what will happen, it will replace the value at index 2, 3 and 4, all right, and insert this value there. Let's see. Let's run our program. So let's print the old list as well. It was here. Okay. So this was our old list 10, 23, 30, 50, right? So here what you saw we did, we said insert from index 2 till index 5. Okay, before index 5. So what is index 5 in this old list? 0, 1, 2, 3, 4, 5. So we want to insert those three values before index 5, right? From index 2 to before index 5. So 2, 3, 4. So we have replaced these three values with our new values. You can also change the size of the list. Let's say I wanted to add four values here, right? So now you will say that you're trying to insert at three indexes, but the values are four, right? What will happen? Let's see. So now you can see we inserted those four values, okay, between index from index 2 to before index 5. Okay, so index 5 was 60, so we inserted these four values before that. So now you can see the size of your list has increased. So that's what I was saying. You can also increase the size of the list. Okay, you can also delete or reduce the size of the list. Okay, let's say I want to say similarly, I want to erase these elements that I added. Okay, what I will do. So now what will happen? You can see when I gave the empty square brackets, it just deleted the elements from index 2 till index 5. All right. So 14 was not at index 5. It was index 5. It was not before index 5. 0, 1, 2, 3, 4, 5, right? So we wanted to in before the index 5. So that's why we deleted 11, 12, and 13. There are some other operations that you can perform on a list. Let's have a look at them. If you want to delete or remove an element from a particular index, you can also do that. All right. Remove from a certain index. Okay. So how you can do that? You can say L1 dot remove. You can see the self completion. It's showing you the option. So I want to remove 50 from my list. So I'll just mention 50 here. So if I print my list after that, you can see our list is missing 50. You can also remove the values at a particular index. So to remove an element from a particular index, there is an inbuilt function called pop. Okay, and as an argument, you can give you the index that you want to remove. Let's say I want to remove from index 1. If I print my list after that, you can see at index 1, 20 was there. So it's removed using the pop function. But if I don't give any argument to pop function, it will just remove the last element. As you can see, it has removed 80 from the list. All right. So one question that comes in mind here, if we remove something that's not there in the list, what will happen? Okay, let's see. L1 dot remove. Let's say I want to remove 150. What do you think will happen? Let's run our program. As you can see, there is a error, value error happening here. Okay. So it's saying the value is not there in the list and you are trying to remove that. So you have to be careful. You have to do proper error handling. We will discuss error handling in the future. So few videos down the line, we'll see that. All right. Similarly, if you try to remove from an index that is not there, all right. So what is the length of our list? 1, 2, 3, 4, 5, 6, 7, 8. 8, right? So let's see if I'm trying to remove from ninth index, but you know that there is no ninth index in your list. So let's comment out this one. If I run my program, there is an error, pop index out of range. Okay, it's an index error. Your index is out of range. There is no such index called 9. Okay. If you want to count the occurrence of a particular value in your list, okay, count a value in list. Let's say our list has multiple occurrences of a particular value. I'll give 30 twice and 60 twice and 20 here and here. All right. If I want to see what is the count of 20 in our list, what you can do, there is an inbuilt function called count, and you can give it the value that you want to count. I want to count 20. So you know that 20 is here 3 times. Okay. So the output will be 3. There is also inbuilt function to sort the list. All right. So it will sort the list in place. So what it means is once your list is sorted, you cannot unsort it. Okay. So if I try to print here, so if I just run L1 dot sort, let's not give this reverse argument. Okay. If I just run my program, so my list is sorted. Okay. So let's try to print our list. Print L1 before sort. So I'll also print it after the sort. So much autocorrection. L1 after sort. Okay. As you can see, we have sorted our list. So now your list has changed forever. Okay. So now you cannot go back to the unsorted list. Similarly, there are reverse functions. L1 dot reverse. This will just reverse your list. Okay. It will also do it in place. So after the reverse, you can see your list is reversed, totally reversed here. One important point is if your list has different data types, let's say you have a list called 1 high true. If you try to run the sort operation on this one, diff list dot sort, it will throw an error. Okay. As you can see, you are trying to compare a string to integer, right? So it has thrown an error. So if I try to reverse this list, right, which has different data types, what will happen? Any guesses? I'll just choose the reverse function here. It will actually reverse the list. Okay, let me show you guys by printing this list. List after reversing. Okay, if I just run my program, you can see we have successfully reversed the list. So how it's happening? When you try to sort it, it's try to compare each value with each other. Okay, because it's trying to compare the first value with the second value and so on, right? And when different data types are there, it's not able to compare and it throws an error. But with the reverse function, it doesn't check what value is there. It just reverses the positions. It just compare the positions and reverses the list. Okay. So this is one interesting bit. Okay. Just keep it in mind. So this is all we wanted to see for the list data type in Python. In the next video, we'll touch base on the other data type, compound data types, such as dictionaries and tuples. Until then, keep coding. I'll give you exercise. I'll in this video description, I'll post a exercise. Just try to do those exercises yourself and paste the solution in the comment section. If you have any doubts, you can also put that in the comment section. Until then, keep coding and please subscribe and like this video. Thank you.